Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. We have a great webinar on tap today, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the webinar, you will be able to access it on demand later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking audience questions. So if at any time during today's presentation you have a question, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your questions. And hopefully we'll have a few minutes near the end of the presentation to go through those questions. And finally, exciting news today, we are going to be giving away 5 $50 Amazon gift cards to our audience members today. So we'll select 5 audience members at random at the end of the presentation, and we'll let you know if you are a big winner at the end of today's webinar. All right, with that, we'll go ahead and kick off today's webinar, which is how to gain a competitive edge with an open source purpose-built time series database. Our speaker today is Chris Chirillo, who is Director of Product Marketing at Influx Data. Chris, thank you so much for joining me today. I hope you are well.
I am well. Thank you so much. It's always so great to be with you guys.
All right, great. Well, I'm going to put myself on mute as always and let you get to it.
Cool. Awesome. Let's go. Let's get right into it. Okay, so today what we're going to do is we're going to talk about why you need to collect timestamp data. Sorry, we have a tiny bit of an echo here. There we go. All right, sorry about that. I had a little bit of an echo in my head. So today we're going to talk about what timestamp data is and why you might find it useful in your day-to-day jobs, and also what are the different ways that you can store that collected timestamp data. And we'll discuss the different types of tools that people have been using for many years, your typical relational type databases, maybe your search databases, and then we'll go specifically into what a time series database is. And then we'll also talk about what the Influx TV data model looks like, so you can see how you can use that to gain a little bit of an advantage. And then we'll also share with you some typical use cases for timestamp data that hopefully you'll find some inspiration from to help you make your projects fly even better. All right, so let's just get to the basic definition of timestamp data. And it's just very simply a timestamp with some kind of a value that you want to be able to use to observe, use for observation purposes. So you could be a timestamp and a temperature reading, a timestamp and the amount of CPU consumed, a timestamp and a number of blade rotations. All these kinds of measurements that you're going to want to be able to look at from one period to the next, 1 minute to the next, 1 hour to the next, to then try to gauge whether that thing that you're observing is doing better or it's running as expected, or maybe there's some kind of hint of a problem that'll help you be able to address it so that you can make sure that your systems are running performantly. There's typically 3 different kinds of high-level use cases that we see when it comes to timestamp data. In the IoT space, I've actually broken that up into 2 distinct segments. And the reason I did that is that although they're under this nice big IoT umbrella, the shape of the data that's being collected is quite distinct. And also the type of technologies that are being used to collect and store that data are also distinct. So even though they're under the nice category of IoT, they're actually 2 very use cases underneath at the technical level. So the first case, we have what the industry has been calling industrial IoT. And these are any kind of manufacturing where they're following some kind of a process. So it's typically going to be some kind of energy production, so oil and gas, agriculture, manufacturing, food production, Also, construction, anything that's trying to follow some kind of a process. They want to, it's like they're following a specific recipe, wanting to make sure as they go through all these very steps that they can have confidence that they're doing this either consistently, or if they do need to make a change in this recipe, they can do that intentionally. And what's interesting about this particular set of use cases is that in the industrial side, the industrial manufacturers have been collecting this kind of data for years. So they've been collecting this data since the 80s. A lot of the factory and the equipment that's there have always been able to collect some kind of value with a timestamp that they can then present to the operator so that the operator can make sure that they can manage the machines within the factory. But what's been starting to happen over the last few years is it isn't enough for the overall factory to just have an understanding that that individual operator is able to interface properly with that piece of equipment. What many people have been wanting to do is they want to also be able to aggregate all that information from all these different pieces of equipment so they can make sure that the process is working harmoniously. There's not any kind of a logjam along the way. And then further to that, they also want to make sure that they can understand seasonality. Are a lot of employees out a certain time of year? Are there certain products that have to get produced during certain times of the year? I always imagine that cookie production probably happens in the summertime in preparation for the Christmas holiday season. So probably that's going to be their busy time of the year. But then you have some industries that are even more dynamic. So when you think about energy production, we're thinking, you're talking about really trying to make sure that you can hit supply and demand levels, which can fluctuate within the day really quickly. And so you want to make sure that the entire factory is running smoothly and it's going to fit all the different parameters from employee schedules, seasonality, also supply and demand from your customers. And so this is quite a lot for these industrial settings to look at. And you can just imagine that just that data that we were talking about now, just understanding how well these machines are working is going to have some kind of value and a timestamp. But the cool thing is what a lot of these factories have started to notice is that the more data that they're starting to bring into the systems to help them understand what's going on, the more data they want to bring in, right? So maybe there's outside temperatures have something to do with their facilities. And so not only do they want to bring in the temperature readings for that day, but they want to bring in the historical data as well as the forecasted data so they can start to predict what's going to be happening. And there may be other kinds of data that are outside of their factory that can have an impact. An example is that when you think about wind turbines, typically what you have is a field of these big wind turbines that are rotating, and they can actually have a bit of a negative impact around humans. So they have something called a shadow flicker effect, where that when the sun is shining and you have a 250 meter tall wind turbine, it's going to cast a really big shadow. Now imagine that the blade is rotating at a pretty fast speed. You can already just start to imagine that that could actually be kind of annoying for a human being. And there's been studies that have shown that that actually causes headaches in certain people. And so with that, some of these operators have to make sure that they don't have their wind turbines running when there are people around. So if you're in a light industrial area, you're going to now have to keep track of what are the working hours of your neighbors. And maybe your neighbors are going to be kind enough to also give you information about when they're not going to be in the office because they have a company picnic or some kind of an outing. And so you're going to want to be able to bring these other data sources into the mix so that you can run your energy production very efficiently. So it seems like every time these people that are running these kinds of facilities get an opportunity to find another data source, another timestamp data source, they definitely want to be able to bring that into the mix. Now, alternatively, under IoT, there's also what we've been calling the consumer side IoT. And in that section, this is where we're talking about the products that typically we'll buy at home. So it could be some kind of a wearable that's going to track the number of steps we're taking. It could be a smart thermostat that we might have in the home. And these things are going to have just a few different kinds of timestamp data that's going to be collected. But the difference here is that it's going to be across millions of users. So in the industrial setting, there's going to be fewer number of devices that are going to be tracked. There may be, 20 different metrics that we're trying to track against each of these devices, maybe a little bit more. But it's definitely not a huge number of devices that we're going to be managing. Whereas on the consumer side, you have millions and millions of users and devices and fewer metrics that are being collected. So if you start to think about the shape of the data, they're very, very different. One's going to be a lot more dense. One's going to be, have higher volumes. And so you definitely want to make sure that you think about those things, because how you ingest that kind of data and how you store that data is going to have definite impact on that, depending on what's actually being put in. So another reason that you might collect timestamp data, and another area where it's been happening for many, many years, is under this umbrella of DevOps. Back in the day, we called this operations. Some people still call it network operation or system operations, infrastructure operations, etc. So it all started when we were monitoring networks, we were monitoring servers, we were monitoring everything that we could find in the physical data center, everything from the power supply, everything that was in the cages and racks, the servers, the databases, the operating systems. And all this has been compounded with this exciting growth that's been happening in this arena ever since the introduction of VMs. All of a sudden you have even more things that you have to monitor. And then you have to monitor all the things that are inside the VMs. And then we also have containers, which is also having an explosion on the number of metrics that are being collected. And on top of that, all of our the software that we're actually writing is not just this one big monolithic thing anymore. We often take advantage of a bunch of different services so that we don't have to create those services from scratch anymore. So back in the day, if you were building some kind of shopping cart, you probably had to build your own kind of credit card processing mechanism. But nowadays, we don't build those things, right? We just go and buy those services, from Stripe or Braintree or whatnot. And there's so many services now. You can buy service for authenticating users, all kinds of different things. Also, there's, data as a service you can get, which is really exciting because now, I feel like we can build things that are much more robust and much more exciting for users quicker. But that also means that we have so much more to track. And so we need to make sure that we can track all the elements that are going in and all the metrics that are going to help us to understand, are those things doing well or not? And hence, we're collecting even more timestamp data in this whole DevOps arena. And then finally, the typical use case that we see for timestamp data is going to be when the data is just really central to your business. And we call that real-time analytics. So this will be things like financial tick data. So you're tracking all the stock trade information. Of course, there's a timestamp, there's a value, which is probably going to be the stock price, and also, which stock it is, and which market it's a part of, etc. All that stuff you want to be able to track in as quick as possible and near real time as possible, because you're going to use that information then to make the determination of what you're going to do next. You're going to trade more, are you going to sell more, buy more, what price, etc. And it's not just with financial tick data. There's also ad trading, buying and trading. There's also a number of instances where the data is just central. It's what their business is all about. That they need to be able to consume this timestamp data to be able to make sure that they can take the next step in assuring the revenue that's coming in for their business. So these are the three use cases that we are most familiar with, and this is what we see a lot of our users doing with timestamp data. Okay, so the nice thing is that there was a survey done last year, and there were some questions that I think you're going to find pertinent to yourself. So one of the questions that they asked was, are you collecting data with timestamps? So this is the data that we just talked about, where there's some kind of value with the timestamp. And not surprising, at least for us, over 80% of the respondents said they were actually collecting that kind of data, which is really cool, because I have a theory that timestamp data is probably the most collected data of all the data that we're collecting in our systems. It might not necessarily be the largest, because graphics, those kind of image data are definitely going to be huge in size. But just my experience, and I think a lot of our experiences as we're building out all these systems, we've always been keen to make sure that our systems are performing well. And so we've been collecting timestamp data for many, many years. And if you just think back to all the data and all the databases that you've created, you'll probably find that's the same case. And you can see from this survey, that was also the case for many people as well. So let's talk a little bit about timestamp data. And there's basically two kinds of time series data that we typically see when we're looking at timestamp data. And the first is something that we call regular. Well, we actually call it metrics, and a lot of people will actually call regular time series. And it's really simply that at every given interval, you're capturing a value. And so you can see we have these really nice smooth curves. And we just want to make sure that at every minute that I want to understand how well my servers are doing, and I'm capturing that information. Compare that to irregular timestamp data or events. So these are going to be things that just happen when they happen. So there's a spike in gas pressure, and it just happens at a given time. It may not be a gradual thing. It just may be something that just spiked. And it could be an anomaly, or it might not be. It might be expected as well. But the point is that you want to be able to capture both types of metrics and events, because both of this information is going to be useful in trying to determine performance and also determining if something is an anomaly or not. And oftentimes it's not as transparent as it might seem. You're just looking at these two graphs, you might think, oh yeah, I'll definitely be able to see, when there's an irregular time or an irregular event that shows up, that's definitely an anomaly. But sometimes that's not the case. So it's important to understand both, and then to understand when you might be able to do some manipulation to that data to really understand if there is a pattern or if there is something that just is a one-time occurrence. So just to reiterate, metrics are regular time series data that are measured at regular time intervals that you define, every minute, every second, whatever it is. Whereas events are just, these are the things that are just going to happen at whatever given point. And so you want to be able to capture both of these kinds of measurements when you're looking at the performance of anything. Now, what's interesting is that, when you manipulate irregular time series, let's say that you take an average of these events that are happening at irregular time intervals, you can now smooth it out and make it into a metric. So you can see we have two examples here where we're summarizing, stock trade prices, which could spike. And since we're summarizing it, we're averaging it every 10 minutes, we're now turning it into regular time series. And the reason we may do this is that sometimes we don't see the patterns, but sometimes when we take a mean or an average, or we do some kind of manipulation to the data, and then we start to look at that data over larger periods of time, we may start to see the pattern a little bit more clearly. Sometimes you don't need to, but sometimes you do. And it's the interesting thing about time series is that you can't just look at it at face value. There's going to be many times where you're going to have to do some comparisons, you're going to have to do some manipulation to understand, is this problematic or not? And it's important because we want to be able to build the proper triggers in our data so that we can automatically scale things up if necessary, or alert somebody, or takes the appropriate action before it becomes detrimental to our systems. So more specifically, time-stamped or time series data is definitely, there has to be a timestamp, there has to be some kind of a value attached to it. It can come in regular or irregular formats. But the other thing that's interesting about time series data is that when you think about it, we're trying to capture information so that if something is not going right, we have enough data so that we can try to determine the root cause. And in all those use cases I described earlier, you're going to be collecting a number of metrics. You're going to be collecting the metrics at various time intervals. And if you just start to think about just even like just a medium data center, maybe I only have a couple hundred hosts. You could just start to imagine the number of metrics I would collect from those hosts over a second interval over the course of just one day, all of a sudden those volumes can be quite daunting. And so it's important to understand that, not to scare you to think that, oh my God, all your storage is going to go away. But on the flip side, you'll have enough data so that you can look at things in near real time and understand that time sensitivity of that data and take the appropriate action. So these are things that, you know, we worry about when we think about time series data. So I think many of us have stored timestamp data in all kinds of forms. I think the simplest way is just, you know, in a CSV format. You can throw it into a spreadsheet. Of course, you won't get very far because it can't store too much. You can definitely throw it into a relational database. Most of us have those lying around. It's easy to create a quick MySQL database. And then eventually you find out that, oh, maybe I need something a little bit more robust. So I might go for something a little more high-end. A number of other people will start to realize, my goodness, this is so much data. How can I possibly wade through this? And so they may opt for a search database, which totally makes sense because you have high volume of data. It makes sense that you want something that can do a really quick query across all that data to try to help to find those patterns. Or sometimes a lot of this data comes in JSON format. So you just think, hey, why not just throw it into a document database? It just seems like a natural fit. And then there's also time series databases. And the reason that we bring that up is that although these alternatives are great, I think they're great entry points. When we think about those characteristics that we talked about in the previous slide, this is what time series databases are optimized for. Time series databases are optimized for the collection side, being able to handle a high ingest rate, also making sure that when you store it, not only does it do compression, but it also compacts the data, because we don't want to eat up all that storage, right? But we really need to make sure that data is there. And at the same time, as we're bringing in all this data, as we're compressing and compacting the data, we need to then hit that data with our queries so we can look at that data through our dashboards, any of our visualization tools, any of our queries to be able to process that data and do something about it. Because at the end of the day, it's all about trying to make sure we can make sense of what our systems are doing so we can take some action on it. So there are a lot of databases that you can use. I just listed a tiny, tiny list. You can use, as I mentioned, MySQL is a really popular starting point. A lot of people will then upgrade to Cassandra or MongoDB. On the search side, they might use Elastic. There's just a ton of different databases that you can use. But there's also a lot of great time series databases that are out in the market. And these are just a couple of examples. KX is a time series database that's really focused on the financial sector. So when you're looking at tick data, many people will choose that. Graphite and OpenTSDB have been in this whole kind of DevOps arena forever. Some of you guys may even remember RRD, which is actually still being used quite a bit. Those are kind of more the traditional kinds of databases, open source tools. And the list just goes on. There are many, many different databases. So going back to the survey that was done last year, they asked, how do you store that time series data? And it's no surprise that a lot of people are still using a relational database. I've done it. We've all done it. So it's just natural that you would do that. But what was really nice is that there is a nice group of people that are starting to recognize that, hey, maybe we should use something that's more purpose-built, like a time series database. You can see we have 12% of the respondents are actually using a specialized time series database. So there is a movement to, making that switch to something that's going to be more built, for this kind of data. Oops. And then, of course, I work at Influx TV, but I was also really excited by the survey that they did mention us. But I was also happy that they were mentioning some of the other time series databases that are out there, because I think it really speaks volumes that, purpose-built is important for this kind of data. And in fact, there's even more data in the market that's helping to underscore this fact. So if you go to a website called dbengines.com, they actually track the popularity of every single database that's out there. And they were probably one of the first ones to recognize that time series actually is its own distinct category. And you can see that in the last 24 months, based on their reportings, time series databases is really growing like crazy. So a lot of people are finding them very useful, and a lot of people are opting to go down that path. I think relational databases are still super important when it relates to time series data. You still need that contextual data. So if we just think, for example, in that industrial IoT scenario, when you have a factory, you're going to store all your timestamp data in a time series database, but maybe information about that piece of equipment. When was the last time it was there was some kind of maintenance on it? What part was used? That kind of information is, I think, still relevant to be stored in a relational database, but you're probably going to want to marry those two together, because maybe that part is what's having an impact on the performance. So you're going to want to have that kind of context when you're looking at time series data. And then, of course, on the right-hand side, you can see just a few of the time series databases that DB Engines is tracking. And I would recommend going to their website. You can see the entire collection of databases under this category. And just a little bit more about this. And you can see Amazon joined us in the mix last year as well. And they're listed. So take a look at it. And the list is quite impressive. There are a lot of time series databases that are out there. So let's talk a little bit about Influx Data. So we are a platform for time series data. And you can see around this circle that there's so many different kinds of timestamp data that we're all collecting. It can be from any kind of sensor, any kind of event that's being triggered from a sensor, all of our infrastructure, applications. We're seeing more and more, our users are marrying infrastructure metrics with business metrics. So sometimes the business transactions might be a leading indicator of something wrong in your infrastructure. So this could be things like, if you're a bank, maybe the number of transactions that your consumers are running through your system. Or if you're an insurance company, the number of insurance documents that are getting uploaded into the system. Sometimes those activity, if there's a slowdown or there's some kind of a change, may actually indicate not that the business is going down, but there could be something in your infrastructure you might want to look at. We've seen this with things like, I think one of our customers is a gaming customer. And they thought they had the right kind of metrics to collect information about how many people are logging in, if there was any kind of problems with logging in. And actually, it was the number of transactions that was the indicator to them that there was something wrong with that login system. When they saw a bit of a drop in the transactions, they started looking at everything else, and they realized, oh my goodness, our users can't log into our system, and that's why they're not playing the games as efficiently as they normally are. And then finally, back to the, the microservice type infrastructure that I alluded to earlier. People are also looking at, of course, custom logs or any kind of logs for that matter that's in your infrastructure, but also looking at the traces, right? Especially if we're talking about using lots of little microservices in our applications, trying to figure out where that bottleneck is. And all of a sudden, we're looking at tiny, tiny spans of time spans that are then, having that might have some kind of problems with them that you also have to track. So all kinds of different types of metrics that can be stored. And in a platform like Influx DB, it's important for us to make sure that we can figure out how we can, instrument our system so we can collect all this information. And it's always going to be different across different solutions that we're creating. And we're doing that so we can observe, look at that data, learn from that data, and then take some kind of action, right? And that is really important with a platform strategy. So it's not just a place for just storing that data, but it's a platform to help you to take action on all four fronts. And digging in a little bit deeper, let me just do the builds. I'm not very good at these things. Okay. When you're instrumenting the data, it's important to be able to make sure that there's many different ways that you can pull that data in. You want to be able to ingest that data really quickly once you've instrumented it, and want to make sure that you can compress and compact that data. And then on the observation front, you want to make sure, oops. It's important that you can bring in that data, but you have to be able to do a query against that data as it's coming in as quickly as possible. Because the whole point is I want to be able to, track that change over time analysis of my data, so that then I can, either do something about it right away, or maybe I want to throw it into a machine learning framework to be able to make some kind of an assessment about the historical data, so that I can do some kind of predictions, and then I can automate my control systems, or, scale things up, scale things down. And then at the same time, what's interesting about time series data is that over time, the actual precision of that data may not be as important to you. And so you want to either aggregate or roll up or evict some of that data. And you want to do that automatically. You don't want to have to build that capability in here, because you have so much other work that you need to do. And so we think it's important, as I mentioned earlier, that time series databases focus on the characteristics of time series data and build the capabilities that are going to help you work with that data efficiently, so you don't have to build those capabilities, and you could just focus on your systems and also working on other features that are going to make you competitive. So we are an open source company. We're really proud of our DNA in open source, and we have 4 projects. At the heart of it is InfluxDB, which is a purpose-built time series database. It's built from the ground up, written in Go, and what that means is that there's no dependencies. It was only built for this particular use case in mind, of making sure that we can handle time series data. So it's not a relational database that you want to shove this kind of data into. This is really built for a specific use case, because we wanted to make sure that we can help developers like yourself use this as a tool, like all the other great tools that are using in your solution, so you can just focus on the competitive features that are on your plate. We have 3 other open source projects. Telegraph is a collector agent, and super popular with the community, and you can use that to collect the data and put that into InfluxDB. We also have Chronograph, which is basically the visualization layer, so you can take a look at the data you're collecting. And then if you need to do some further manipulation of the data, we have Capacitor. But as a platform, you don't have to use all 4 of these. You can pick and choose, and I'll talk a little more about that in a sec. We do have to make a little bit of money, so we do have 2 commercial offerings. So a number of people have asked us to build a SaaS version, so we call that Influx Cloud. So it's fully managed, hosted, but you have all the great capabilities. And then we also have, we've also made the decision to close source a couple of features like clustering, and we call that Influx Enterprise. And typically that's going to be, companies that feel that they have a HA requirement for this kind of data. But I want to make sure that everyone walks out of here knowing that our open source projects are super powerful. And probably, if you talk to a number of our sales guys, they probably think that even our open source projects are the biggest competitor to them, which is kind of funny, not for them, but it's kind of funny for us, because we've made this project so powerful that some incredible projects out there come from organizations like CERN. A number of big retailers out there are really relying on just our open source projects, and they are super content and really happy with the performance of that product. So please don't equate open source with cheap, junky, not something that you can use in production, because that's not the case at all. Just taking another view of our open source project. So InfluxDB is where you would store the time series data. And typically it's going to sit underneath the projects that you're building. And you could use it on its own. You don't have to use any other components of the TIC stack, as we like to call it. TIC meaning Telegraph, InfluxDB, Chronograph, Capacitor. You can write data into InfluxDB with Telegraph. There's already 200 plus plugins that the community has built. So the nice thing is these are subject matter experts on very specific data formats. and they've built these plugins for you. So there's a ton of them that are out there, collecting all kinds of metrics from your containers, your orchestrators, your sensors, etc. Alternatively, you could write your own. It's really quite simple to actually do it. We have a number of trainings that can show you how to do that. You can also use HTTP to write data in, or we also have a number of client libraries. So Java, Go, Python, JavaScript, etc. So you can write data directly in with those client libraries and just use those things. And then as far as visualization, I'd say that probably the most popular visualization tools that our community members are using is going to be the dashboarding or graphing tools that's built into their applications. So let's just see, like if you're talking about a home thermostat product, typically it's going to come with a smartphone app for the consumer to be able to look at, and there's going to be some kind of graphing capability in that smartphone app that's actually querying InfluxDB for the time series data. That's going to be like a very typical thing. There'll be some kind of homegrown dashboarding capability that's built into an app that's then presented to your customers. And then as far as more the internal kind of a dashboarding, you can use Chronograph, which will let you look at the data as well as do some simple dashboarding. Or another super popular open source visualization tool is going to be Grafana. And so we have a lot of people that are using Grafana on top of InfluxDB. And then with Capacitor, probably the most popular thing that people are doing with Capacitor is that this is where you can define your alerts, and then you can have them interface with a number of incident management projects or products that are out there, like PagerDuty, VictorOps, Opsgenie, Alerta, Slack, etc. The list goes on. Oh, I forgot to mention, there's another way that you actually can bring data into InfluxDB, and that's actually you can also pull data. So you can use the service discovery mechanism that Prometheus introduced and bring data into InfluxDB, which is pretty cool because I think push and pull both have their merits. And I think having the combination of those two is going to make sure that the right level of metrics are coming in, not completely flooding your networks. And also making sure that we can minimize the amount of work it is to collect that information. And then finally, we have a lot of users that are taking this data and they're throwing it into some kind of machine learning framework. A lot of times they actually bring that trained data back into InfluxDB so they can make a comparison, or they can use both data sets in the work that they're doing. And there's also a couple of open source projects that are, that you can also try that could do that. There's also a commercial project by a company called LoudML that really they've actually built in some capabilities into Chronograph to make pulling that data into InfluxDB that simple, which is really one of the cool things about open source is that, anybody can contribute to these projects and just make the projects that much more powerful. So why InfluxDB? Well, it's very, very easy to get started. It literally takes just a couple of minutes to install. You can start, I recommend that you just start, just configure Telegraph to pull the system metrics from your laptop so you can see the kind of data you can bring into a time series database. The query language is really simple. It kind of looks like SQL. There's no external dependencies. You can, if you have a ton of data come in, you can easily horizontally scale it. And as a part of a platform, you can kind of pick and choose the various components that are going to fit underneath the solution that you're working with. All right, so let's talk about what the data looks like. And we'll just use a very simple example that we can all understand very easily. So we're just looking at stock price for 3 different stocks over time. We have stock A, stock AA, and then stock Apple. And we're going to take a look at how we're going to bring that data into InfluxDB. And I can explain a little bit more about the tagging capabilities, as well as how you can bring in multiple values within a single measurement. Whoops. I keep hitting this too quickly. Okay, so in this particular case, my measurement is going to be called stock price, which is the label of my graph. And the way that you bring in data into InfluxDB is kind of a comma separated. It's kind of a CSV format. It's kind of our own little format. But you'll see it's really easy to understand. So we have the label of the measurement, which is called stock price. And then I'm going to actually bring in this particular case, just one value, which will be the price of the stock at given time intervals. And then what I'm going to do is I'm going to tag that information with the actual stock name and then also the market that it's in. So looking at the bottom at what we would actually throw into InfluxDB, we have our measurement name, which is stock price, separated by a comma. We have our two tag values that we're going to bring in. In this particular case, we have the ticker and then the market. Then separated by space, we have our field, which is our value of price. And then separated by another space is going to be our timestamp. So pretty straightforward and quite powerful. And I actually have a couple more examples to share with you, but here we go. So here's our measurement separated by a comma, our tag set separated by space, our field step, and then separated by the timestamp. In this particular case, we have two tags and one field, but if I wanted to, I could actually have multiple fields. If I wanted to have multiple values brought in at this particular timestamp, I can do that as well. So here's just a different example, and you can see here that in this particular case, whoops, darn it. Sorry, I just lost my. Oh dear. I just lost my presentation.
It's here. Can you go online?
Just give me a second here.
Okay.
There we go. All right. Oh, I don't know what I did there. Okay, so we have another example here where our measurement is CPU underscore load separated by comma. And in this particular tag set, what we're capturing is host name as well as some location information about where these things are. And then you can see I have two values. So I have a field set of temperature and volts, and then I have our timestamp, just so you can get a sense of the kind of things that you can do with time series data. So you can see here we have, just one more time, the entire series as a whole is going to be your measurement and the tag set. So that's going to be all those points that we're collecting. And then if you just want to talk about a single point, that's going to be at that particular time set and the data that we're collecting. So it's pretty simple. I'd say the trickiest part is that just getting familiar with these terms when you look at our documentation, because we talk about these things in the context of the vocabulary that I just described very heavily. So it's just important to understand that. Here's a couple different examples. So let's look at the middle one. So you can see in this measurement we have temperature. I have two tags, zip code and country. I have two fields, which are my two different values, value and humidity. And you notice that I don't have a timestamp in this particular case. And that's because you don't have to have a timestamp. So the moment the data is written into InfluxDB, and if there is no timestamp, then we'll actually automatically append a timestamp. But I always recommend that you do add a timestamp, because you're probably going to want the timestamp from the moment that the data was captured, not the moment that you insert it into InfluxDB. But you can see it's very flexible. So in the last remaining 5 to 10 minutes, I'm going to go into some very specific use cases. So now's a really great time to get your questions ready so we can make sure that we answer them before we hand it off for the really cool drawing for the gift cards. But I have a couple of use cases that are very different from each other. But I think the thing that is the same across all these different use cases is that these developers are using these open source projects underneath the products that they're either using internally or selling to their customers. So it's really meant to be a set of tools for all of you developers that are out there so that you can focus on the cool features that you need to focus on. So the first example is a company called World Sensing that are based in Barcelona. And they actually have a smart city solution where they have Influx DB living underneath it. They actually initially started with just using it to monitor their servers, just their normal infrastructure. And they started out as a hardware company that were building sensors that they would place into cities so that cities could be responding to emergencies a lot quicker. So they have sensors in traffic lights, they have sensors in parking lots, they have sensors throughout the city so that first responders can know, where some of the jams are so they can avoid them. They also happen to use that data to let us citizens know where the jams are or where we could find parking in different parts of the city. So trying to make it so that our lives are definitely a lot better. They also use it in a number of construction sites for safety purposes. So they have a number of sensors that are used in like deep mines or in tunnels as they're building out train lines to make sure that the environment is safe for the people that are working in these locations. So they started out as a hardware vendor and then started to realize that it's not enough to just build those sensors. They needed to build an overall solution that they could sell to these various cities or construction sites to be able to really harness the data that's being collected. And they happened to look at InfluxDB a little bit differently one day and realize, hey, we can use that not just for monitoring our servers. Why don't we use it as a time series database underneath our overall solution? And so that's what they've currently done. And so it actually serves as the data store for all that data that they're collecting from the sensors that they have throughout their solution. And the nice thing is they can take advantage of all those different collection methods. So it fits with their environment. So they don't have to change how they work. They can just make sure that InfluxDB works in a way that's going to be efficient for them. Another kind of an IoT use case is with ANS Energy. It's an energy producer that burns non-recyclable wood. So they have been doing this for a number of years. And they had a lot of legacy systems that they were feeling really uncomfortable with because it was already end of life. They also, unfortunately, even though they put in a lot of this sensors, their number one technology that was being used to track this information was actually paper and pen. So a lot of their operators were still just collecting those values on paper, making the adjustments, the equipment, and then sometimes that data was given to the supervisor, sometimes it was lost, so they didn't have very great historical record keeping. And they really wanted to make sure that they could become a lot more efficient and really fulfill the demands that their customers were placing on them. So they actually went to a company called Factory. It's a solution provider in Belgium. And the guys at Factory have built a data historian that uses InfluxDB in the back end. So once again, we're appealing to the people that are building these kinds of solutions, and we're a really great and important component of the Factory Data Historian solution that ANS Energy uses. On the SAP front, we're actually more in the kind of a DevOps use case. So we got started in the Ariba line of business. And basically they were just using us to just kind of track the performance of their infrastructure and slowly built out to use it more and more within SAP. And for them, it's really about, it's more of an internal tool, but because they're such a large organization, they have to build these tools so that many developers and, many people in the operations team can be able to throw data into these systems and also be able to access that data. So in a way, they're kind of like a little mini network infrastructure monitoring tool where their customers are their own employees. Another different use case is that Wayfair uses us to make sure that they can monitor all the changes that they're putting into their application. So for those of you who don't know, they are a big furniture retailer in the US, and they have a lot of changes that get thrown into their systems. They're constantly adding new products. They're constantly figuring out new ways that they can make these products appealing to their customers with maybe different kind of pricing, different kind of combinations. They use a lot of AI to try to figure out, what best combinations are going to be appealing to their users. And they actually rely on not just synthetic monitoring, but also real user monitoring to make sure that these systems are always performing really well, so that even at their busiest times, they can continuously add changes to their website and not have a negative impact on their sales. They also have a pretty interesting. They also monitor all the backend infrastructure with InfluxDB, and they were previously a graphite shop. And so they were already familiar with open source tools, and then just felt that graphite was it didn't have as a robust community anymore, and they needed to make the switch over to InfluxDB. PayPal, they have always had a centralized monitoring team, and they needed to continue to build out that centralized monitoring to make sure that they could service all the multiple teams that they have that were responsible for monitoring the code that they're actually building. And this was across the board, across all the different properties that they have. And, once again, think of this as like a set of developers that are trying to build a solution for a really large group of developers internally to PayPal. And so they had to make sure that it was really easy for those developers to be able to put in the information and get the information out on, especially as it pertained to the code that they were writing. And then finally, another example is MuleSoft. And, with their Anypoint monitoring solution, they're actually using Influx Cloud as a way to not only monitor how well the APIs are doing and the connections that they're making, but they also provide that as a service, as a part of their service, where they actually show dashboards about the performance of these things to their customers. So they really have it embedded within their solution. So it's not just using it internally. This is actually turned into a real nice value add to their customers. So 6 very different use cases, but I think the key thing you can hopefully appreciate is that, we're really a set of projects that are just perfect for the development community to be able to embed into your solution. And with that, I'm going to open it up for questions, and hopefully I won't mess up my presentation again.
I think you'll be fine. Okay, so we have a ton of questions. So I'm just going to dive right on in, and then we'll stop at about 3 minutes to the top of the hour so I can do the drawing for the 5 gift cards. First question. Let's see. How is IOPS performance if we use InfluxDB?
So it's going to depend on, so with any kind of performance question, I'm going to always preface it with saying it's always going to depend on what your data looks like. We have a bunch of benchmarks that we've open sourced that you can take a look at. The benchmarks are on the website. They're also on GitHub. And benchmarks always come with a little bit of a bias. I know that, you know that, but it depends on what your shape of your data looks like. So is it going to be lots of metrics? Are you going to tag it a ton? Are you going to, is it at really tiny intervals? So I just want to caveat it with that. But with that, I feel pretty confident that when you look at the benchmarks and then you even try it yourself, that you will feel that it's quite a performant, nice little time series database.
All right, great. So the next question then, is data stored in key value pairs or columnar or semi-structured or NoSQL?
Yeah, almost all the above.
Yes, the question is yes.
Yeah,
The answer
I mean,
yes.
yeah, it's like all above. I mean, the cool thing is it's, you don't have to think about your schema. You can just start, pulling in data. Once again, little asterisks. Although, I do think you should think about what kind of tags you really want to add onto the data. Personally, I got a little too excited when I started. I just tagged the heck out of my data, and then it got really ridiculous. I was having a hard time building dashboards because I couldn't remember what the heck I had in my schema. So I just say, just be careful. just think about what are you really trying to build as far as a dashboard or an alerting framework, because it's really easy to add these things, but super simple. And yeah, and it's just, stored as, as we described in that, in our CLI, you have your measurement name, you have your tag, which you're going to use to group by, right? If you think about like why I would have a tag, it's so that I can then, separate out the data and just look at certain things. So if you think back of that stock price example, I might want to look at just NASDAQ data, or I might just want to look at New York exchange data. And then you have your values, which, the nice thing is when you have it in a single measurement, it's nice to have multiple values so you can really do some nice comparisons.
All right, great. Next question. Are there any SaaS offerings of Influx and cloud platforms like AWS, Azure, or Google Cloud?
Yeah, so today we have a SaaS version called Influx Cloud, and it's currently sitting on AWS. And then our Influx Enterprise product, or actually even our open source project, you could easily put those into, whatever cloud that you might already be using. If you go to the various marketplaces on, Red Hat, AWS, IBM, all the big cloud guys, and you go to the marketplaces, you'll see the open source projects as well as Influx Enterprise posted there.
All right, great. I think we have time for one more question. What emphasis does Influx Data place on open source compliance and scanning?
Not really sure what that means. It could, that's kind of maybe we can get a little bit more details on that. It's a little bit too broad for me.
Okay, all right, great. Well, we are 3 minutes to the top of the hour, so at this point I want to close out the questions. If we didn't get to your question, please know that the folks at Influx Data will have a copy of all of the questions that have come in, and I'm sure they'll be more than happy to follow up with you offline. But for now, drum roll please, let's go ahead and pick our 5 winners of the $50 Amazon gift cards. And our first winner is Alan Barrier, and I apologize if I have mispronounced your name. Alan, thank you for listening, and congratulations, you are our first winner. Our second winner is Doug Smith. That's an easy one. Congratulations, Doug. Let's see, our third one is Janine Petoskey. Congratulations, Janine. You are our third winner of the $50 Amazon gift card. And our fourth winner is Linda Stocker. Congratulations, Linda. And for our final $50 Amazon gift card, the winner is Ramakanta Panagrahi. And again, I apologize if I mispronounced your name, but congratulations, you are our fifth and final winner of today's drawing for the 5 $50 Amazon gift cards. So congratulations to those who won, and thank you all for joining today. Chris Cirillo, thank you as always for giving such a great presentation. It was great. I got a lot out of it, and judging from the number of questions we had, the audience did as well. So thanks so much.
Thank you, and we'll make sure we answer those questions.
Awesome, awesome. Well, just a quick reminder that today's event has been recorded. So if you missed any or all of the event, or if you just want to listen to it again, you will have the opportunity to do so. Check your email later on today for an email from us that includes a link to the webinar on demand. And for some reason that doesn't show up, please be sure to check out the DevOps.com website for it. It will be living there as well. Just go to the webinar section on the website, click on demand, and it should be right there waiting for you. And then while you're there, please go ahead and check out the other webinars that we have listed on the site, both upcoming and on demand. Hopefully there'll be something there that you're interested in. Again, Chris, thanks again for being here today, and thank you also to the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.